Let's recall why bonding actually occurs. It occurs to get that full outer shell. Remember, we want an octet, the octet rule, except for elements 1 through 5. They only want 2 because it's in the 1s. Let's not worry too much about them. Let's focus on the octet. Ionic bonding is one method of forming an octet. Ions, which are cations and anions, are attracted to each other. Remember, cations lose electrons easily, and anions gain electrons easily. That means cations are metals, anions are nonmetals. They're the extremes of the ionization energy and electronegativity. Cations have low ionization energy, anions have high electronegativity. If you look over here, you see that sodium has 1 electron on its outer shell. Chlorine has 7. Sodium gives its electron to chlorine, forming chloride. What's happened is the low ionization energy of sodium has allowed the high electronegativity of chlorine to pull its electron away. What we are left with is a sodium plus and a chloride minus, and they're attracted to each other and basically stick together. In ionic bonding, electrons move from elements with low ionization energy, which we saw were metals, to elements with high electronegativity, the nonmetals. Recall, you've got a stair step right around here. You've got metals over here and nonmetals on the right, except for hydrogen. We see this situation again. Sodium chloride is actually just Na pluses and Cl minuses attracted to each other. Now, this attraction is called electrostatic attraction. They basically stick together. Let's look at the octet. Sodium has 1 on its outer, chlorine has 7. When sodium donates its 1 electron, and I use donate kind of tongue-in-cheek when chlorine pulls the electron off of sodium, sodium now has a full outer shell. There are 8 electrons. Chlorine, which is now called chloride, has 8 electrons on its outer shell as well. They both have an octet. The positives and negatives stick together, and it actually forms a crystal lattice just like this. Positive, negative, positive, negative, negative, positive, negative, positive, and it gets bigger and grows. Let's look a little closer at cations and anions. Cations are either metals or polyatomic ions. The only polyatomic ion that you have to memorize that is a cation is ammonium. Anions can either be nonmetals or polyatomic ions, and you have a lot of those to memorize. Let's see some examples. Na plus and Cl minus makes NaCl. A metal and a polyatomic ion, so calcium and the sulfate, you put them together, calcium sulfate. If we have the positive polyatomic ion, ammonium, we can put that with just a regular nonmetal, and we get ammonium chloride. We can take that polyatomic as well and put it with another polyatomic, just for fun, and you get ammonium nitrate. You might recognize ammonium nitrate as the key ingredient in a lot of fertilizer bombs from TV. Now, formula units. These things that I have right here are called formula units. These are the lowest ratio of ions. We are forming big crystals, but we don't say Na 10 billion, Cl 10 billion. We look at the smallest unit. Now, how does this happen? You can't consider ionic bonding as occurring only with one cation and one anion. They don't form single molecules, they group together. This grouping we call a crystal lattice. It is a regular repeating pattern. It maximizes attraction and minimizes repulsion. So this plus and this negative got together, but then this side is still negative. And you look over here, this side of this combination is still positive, so they're attracted to each other, so it pulls it in. And you get a lot of these, and you wind up with this piece right here that eventually builds in 3 dimensions, and we get the entire lattice. Here are some examples of crystal lattices. They come in all different shapes and sizes. This one right here, for example, is copper sulfate. It's one of the ones we made earlier, and that's the alum, which has a really long name, but we just call it alum. And this, to me, looks like NaCl, as does this. This looks like a top-down view, but you get stuff, I think that's beryl, I'm not sure, but you get amethyst, topaz. These shapes are naturally occurring, and they occur because of the ionic bonds. Sodium chloride is incredibly simple. You've got a plus and a minus, and a plus and a minus, and their size is, you know, pretty similar, so they just pack in as tightly as they can. Other covalent compound, no, how about other ionic compounds? You've got big minuses and teeny tiny pluses, and so they have to orient themselves differently. So we get all kinds of shapes because of that plus-minus orientation. Let's talk a little bit more about formula units. Formula units represent the lowest whole number ratio. So remember, rather than sodium 10 billion, chloride 10 billion, it's just sodium 1, chloride 1. The cations and anions combine together in these whole number ratios to form something that is neutral. So for example, if you have a plus and a minus, they neutralize each other. If you have 2 pluses and a minus, you're going to need 2 minuses. Let's do a for example. You have a 2 plus and a 1 minus. Well, right now you've got a 1 plus more than you need, so let's put another 1 minus, and we are neutral now. We're going to play with this. And notice I've got the crystal here, and the formula unit is right here. Just to remind you of the charges, so 1 plus, 2 plus. The D block have variable charges, and we'll talk a little bit more about those, but for now I will have to tell you what the charge is on the D block metals. 3 plus, 4 plus, 3 minus, 2 minus, 1 minus, minus 1, and 0. These grayed out boxes right here do not form ionic compounds, only covalent compounds. These do not form ionic compounds either, these noble gases. There is some variation as you go down the groups, so just be aware of that. Now, here's how we create the formula unit. The first thing we do is give each element the assigned charge from the periodic table. So if we put sodium and chlorine together, we give sodium a plus and chlorine a minus. We want it to neutralize each other. We've got a 1 plus and a 1 minus, so we only need one of each. So we can say NaCl. Is it the lowest ratio? Well, it's a 1-to-1 ratio, so yes, the formula is NaCl. That may have been too easy. Let's go to the next one. Barium. Barium is in the 2 plus column, and chlorine is in the 1 minus. So you've got a 2 plus and a 1 minus. 2 plus and a 1 minus, so you need another 1 minus. So BaCl2. These are the chlorines, which are now chlorides, and this is the barium. So is it the lowest whole number ratio? It's a 1-to-2. Yep, that's the lowest. So the answer is BaCl2. Let's go to sodium and oxygen. Sodium is a +1, oxygen is a 2-. what we have is a 1 and a 2 minus. Well, that doesn't equal each other, so we need another 1 plus. So we have 2 NAs, that's right here, and 1 oxygen. Is 2 to 1 the lowest ratio? Yes, so Na2O. Let's keep going. Let's do some more. So Mg is a 2 plus, Br is a minus. I'm getting these from the periodic table. If you're not looking at the periodic table, you will get these wrong. This is where we get the information. So we have a 2 plus and a 1 minus. In order to balance this, we need another 1 minus. That means we're going to need 2 bromines. So MgBr2. And it's actually bromine since it's a minus. It is the lowest ratio, so the formula is MgBr2. Let's look at this one. Aluminum is a 3 plus. Oxygen is a 2 minus. Ooh, 3 plus, 2 minus. Wow, I don't know a lot here, but I do know that the lowest common multiple of 3 and 2 is 6. So let me get to that 6 and see what happens. So if I do 2 3 pluses and 3 total 2 minuses, so this is a 6 plus, this is kind of my head. I'm not, actually, this isn't actually true, but I've got a 6 plus and I've got a 6 minus because 2 and 2 and 2. It balances. So I write Al2 because I need both of those 3 pluses, O3 because I need each of those 2's. Is that the lowest common ratio or lowest ratio? Yes, it is. Al2O3. NaS. Na is a plus, S is a 2 minus. We've got a plus, 1 plus, and a 2 minus. So to balance that, we need another 1 plus. So we need 2 NAs and 1 sulfide. It is the lowest ratio, so I'm going to go ahead and box that. Let's look at barium and oxygen. Barium is a 2 plus, oxygen is a 2 minus. I've got a 2 plus and a 2 minus. Well, that balances out, so it's BaO. And 1 to 1 is the lowest ratio. K plus, I minus. So a 1 plus and a 1 minus, so Ki. 1 to 1 again. Beryllium and nitrogen. So beryllium is a 2 plus, nitrogen is a 3 minus, and it becomes nitride. So I've got a 2 plus and a 3 minus, so we're talking 6 again. So in order to get to 6, I need 2 additional 2's, so it's a total of, let's do my head work, this is a brain bubble by the way, 6 plus. And then if I want 6 minus, I need 2 3 minuses, so I get 6 minus. So let's see, that's 3 berylliums I need and 2 nitrogens. Be3N2. That's the lowest ratio, so that's my answer.